Okay, good morning, everybody. What we're going to do today is we're going to focus on how to figure out the interior angles of a polygon, but that's what we did last time. We talked about how to find the sum of interior angles. Today, what we're going to do is we're going to talk about like individual angles and how they relate to regular polygons and to irregular polygons. Okay, so what I want to do is I want to start off with on part one and just kind of go over the sum of interior angles. And I would highly recommend that when you guys do these, like you're going to want to have these written down. And I know some of you don't print out your notes, you can write them out. But this is definitely something you're going to want to have handy or nearby when we're working on these problems, because you're going to want to know how many degrees are in a pentagon. You want to know how many are in a heptagon, or any type of polygon. The first one's kind of done for you. Obviously, a triangle has 3 sides, and it's made up of just one triangle. And if you use that the formula for the interior angles of a triangle, you're just going to do 180 times n minus 2. You know, so if you that kind of follows this rule. And, 180 times 1 is just 180. Now, if it's a quadrilateral, whether it's a square or if it's a rhombus or just a trapezoid, it doesn't matter what it is, really. Obviously, it has 4 sides, and you can draw 2 triangles in it. Now, remember, you're not allowed to overlap the diagonals that you make. So that's not allowed, so you can make 2 triangles. And then that's going to follow this rule, which is 180 times 4 minus 2, which is 180 times 2, which is 360 degrees. Okay, like I said, you're going to want to have those numbers handy. You're going to probably want to know that a triangle's got 180 degrees, that a quadrilateral is 360. Going to the pentagon. Now, a pentagon has 5 sides, obviously, and you can inscribe 3 triangles inside of it. So a pentagon has a total of 540 degrees. Now remember, when I'm talking about 540, I'm not saying that that angle right there equals 540. What we're saying is that all the angles, when you add them up, there's 5 angles in a pentagon, obviously, and all 5 of those add up to 540. Okay, so then when we get to this one right here, which is n, if it's n-sided, that there's no actual number here as to what the number of sides are. So we're just going to put n, and then the number of triangles is always going to be the number of sides minus 2, and then the formula is always going to be 180 times the number of sides minus 2. That'll be the measure of the sum of all the angles of any polygon. So like I said here earlier, make sure you guys have these notes down and these numbers somewhere, because we're going to revisit these numbers. Like I said, we're going to revisit those numbers. You're going to need to have those somewhere handy on a note card or on your notebook paper or on the note sheet that you have right here if you printed this one out, which I would highly recommend having. I think some of you, when it comes down to a test and quiz, you're going to be allowed to use your notes, of course, because you're all at home and you guys can do that. So you're going to want to have these things handy. Maybe a few days from now, you're going to think it's a ridiculous request for me to say, well, a heptagon, as you know, has 900 degrees. And you're going to be like, how do I know? How am I supposed to know that? Well, it should be in your notes. Heptagon, you should be looking at a heptagon and you're like, oh yeah, I've got that written down. Or If I refer back to a pentagon and you know that a pentagon has 540 degrees, you're like, how does he know that? Well, because it's part of our notes. So we have that written down, or not that just it's part of our notes. I know what the what's the formula for deciphering 540 degrees. Okay, for part 2, what we're going to do is we're going to look at the measure of one interior angle. Now, a lot of these problems depend on you knowing how many total degrees there are in a pentagon, or how many total degrees there are in any polygon. You should also notice that these numbers right here, these numbers that you get, that does not matter if it's regular or irregular. These numbers are just telling us the total number of degrees in any one particular polygon. You know, so there's 1,080 degrees in an octagon. That is not how many degrees there is in one angle. That's all 8 angles add up to 1,080. All 9 angles of a nonagon add up to 1,260. Okay, now back to part 2. Like I said, we're going to look at the measure of one angle. And I know I have a protractor here. You don't have a protractor on your page, but I'm only putting that protractor on here so that I can kind of prove to you what's going on here with these angles. So I'm going to kind of just put that off to the side for right now. And then what we're going to do is we're going to figure out what x is first. So we're going to figure out what that x is right there. Now what we have is, this is already, it tells us, it says it's a regular octagon. Now a regular octagon means that all the segments are the same length and all the angles are the same measurement. Well, now we know, if you can just go back to your notes, you know an octagon has 1,080 degrees. Okay, so if this is a regular octagon and we know that all these angles are the same measure, well, we're just going to take 1,080 and we're going to divide that by the number of angles. So we're going to do 1,080 divided by 8. And this is, of course, you can use your calculator. 1,000 divided by, or 1,080 divided by 8 is 135, okay? So all these angles are 135 degrees. This one's 135 degrees. This one's 135 degrees. And we know that because we know it's regular. And since it's a regular shape, every single angle is the same. It's very predictable. Right? For instance, I'm not asking about line segments, but if I said this segment here was 7 centimeters, well, then you can predict that this is also 7 centimeters. This is 7 centimeters all the way around. Okay, but that's really not what the point is. We're really just looking at the angle measurements here. One angle of a regular octagon is 135. That's 135 degrees. And I'm just going to kind of prove that. I'm just going to take, okay, so what I did was I just kind of set up that angle. I set up that protractor on that angle, just one of the angles. It doesn't matter which one it is because they're all the same. And what I'm doing is I'm just going to look at this right here. I'm just going to extend that ray. But that ray, if you notice, it goes right between 130 and 140 degrees. Well, what's halfway between 130 and 140? Well, yeah, the 135 degrees is there. So that's it. I don't expect you guys to use a protractor for these. What I expect you to do is use good solid arithmetic and good math, good understanding of the rules of angles to figure out what they are. But if all I'm just kind of doing here is just confirming that it was 135 degrees. I don't expect you guys, like I said, to use a protractor. And this next one here, we've got an example of an irregular octagon. Now, what makes it irregular is that not all the segments are the same. Obviously, that segment is longer than this one. Obviously, this angle is not the same as that angle. So the angles, not every one of them, I mean, there might be a couple that are the same, but what makes a regular shape regular is that all the angles, all the segments, every single one of them are the same measure. Okay, so what we have to do is we have to set up a little bit of algebra here. So we're trying to figure out what m is. So I'm going to set up kind of an obnoxious looking equation here. So I'm going to do m plus 157 plus 153 plus 110 plus 148 plus 140 plus 145. And I know what you're thinking, but I'll talk about that in just a second. Plus 118. And we know, since this is an octagon, now it doesn't matter that it's irregular, but we know that since that is an octagon, we know that it has 1,080 degrees in it. All right, and we can just kind of refer back to our notes that it's 1,080. So I'm going to set all that stuff, all those numbers, equal to 1,080 degrees. Now here's the part where I think some of you are like, all right, I'm not going to write all those numbers down, which I totally agree with you. If you want to go ahead and just add those up first instead of writing all those down, that would make more sense. But I'm just kind of doing that just to kind of show you what the whole setup looks like. So you're going to want to add all those up. So make sure when you're adding a lot of numbers that you're double checking, you're not just putting it in your calculator once. But I got 971. If you got something different, go check your arithmetic. Now I'm just going to solve this by taking 971 away from both sides. So you're going to do 1,080 minus 971. I get an answer of 109. And that makes sense. M equals 109. I think sometimes when people do this, maybe they didn't add up the numbers right, and then maybe you got M equals 250. Well, that's greater than 180. That would be a reflex angle. Now, straight line is 180 degrees. So I don't have any concave angles on this at all. So that wouldn't make any sense. So make sure your answers are making sense. Also, on the other end of the spectrum here, you might have like, well, let's say M equals 15 degrees. Well, that definitely does not look like 15 degrees either. You can't always base it on how it looks. So you might want to double check that if you're getting these crazy numbers. But yeah, M equals 109 degrees. Example C right here is talking about a regular pentagon. Now, a regular pentagon, again, go back to your notes and look at how many degrees are in a regular pentagon. Okay, and right here, according to your notes, you have 540 degrees. And so now we're going to go back to the problem and just kind of keep that in mind. Now, we're just looking for x, and this is a regular pentagon. All we're going to have to do for that one is just do 540 divided by 5. I'll be a little bit more systematic about this. Let's kind of talk about what these numbers. So the top number represents the sum, the total sum of the interior angles. And the bottom number, the number that we're dividing by, represents the number of sides. It also represents the number of angles. Doesn't matter how you think of that, because the number of sides will always be equal to the number of angles and vice versa. All right, so 540 divided by 5 will tell you what one of those angles equals. And you get 108. So every one of these angles is 108. And if you don't trust that answer, just add up 108 5 times, or just do 108 times 5, and you should end up with 540. So that's 540 degrees right there. Now, this is an easy problem to do because we knew it was regular. Regular shapes have the same angle. Every angle is the same. Now, the next one is same thing. We have a pentagon. However, it's not a regular pentagon. It's a irregular pentagon. We're going to do what we did last time, and we're going to set up an equation. So just let's figure out what all those equal. So 118 plus 129 plus 108 plus 95, and I get 450. All right, now what are we going to set that equal to? We're going to set that equal to how many degrees are in a pentagon, and that's 540. So just so you guys know where we got these numbers, 450 degrees right there, that's what the angles that we have. The angles given is 450 degrees. A represents the unknown angle. We're not sure what that is. That's what we're going to solve for. So that's your unknown. So you want to, a lot of times you got these numbers, okay, and you're going to add those up, and that's what the angle's given is going to be. So now we can just go ahead and go through and just solve this. So we're going to take 450. These numbers are very similar looking, and you're going to solve them. So you get 540 minus 450, and you get 90 degrees. And that kind of looks like, I don't think when I drew these up, I don't think I made them to scale. Yeah, but that's 90 degrees right there. That's a right angle. Okay, moving on to example E right here. Now this is an example where we don't have any picture to go with it, and you shouldn't need a picture. If you know kind of the general idea of what's going on with regular shapes versus irregular shapes, then you know how many degrees are in them. Now this is a regular decagon. Now a decagon has 10 sides. That's a 10-sided polygon. You're going to look at, if you could look at the first sheet there, you're going to look at what a decagon has. All right, so a decagon has 1,440 degrees. Okay, so to figure out what one angle equals, what does just one angle of that decagon equal, we're going to do the sum of the angles. Now the sum of the angles is 1,440. And then we're going to divide that by how many sides there are, and that's 10. And so 1,440 divided by 10 is 144 degrees. So every angle of a decagon, as long as it's regular, is going to be 144 degrees. All right, I'm not going to attempt to draw that, but if you had a picture of it, you could put 144 in at every vertex there, knowing that it's regular. Now the next example here is just, again, just like we were doing before, is we have a bunch of angles. All right, we have 10 angles, 132, we have 150, 149, 129, 162, 143, 160, 132, 142, and x. I mean, I know there's only 9 numbers given, but a decagon has 9 angles. So we're going to set this up so that it's x plus and whatever all those other numbers add up to. All right, so when you add up all those angles, you get 1,302, and then we're going to make that equal to the sum, which is 1,440. Okay, so just kind of breaking down what we have here. This is x represents our unknown angle. This represents what we do know, that's the known part, and the 1,440 represents the sum. What do all the angles add up to? And we knew that it was 1,440 because that's what we kind of figured out before. So we're going to take away 1,302 from both sides. And I got x equals 138. Okay, at this point, why don't you go ahead and pause the video and try this one on your own without my help and see if you can get it. This one's asking how many degrees are in one angle of a regular nonagon. Nonagon has, let you look that up. Nonagon has some number of sides, between 1 and 100 sides. I'll give you that hint. And an irregular, this is missing a word. This should be an irregular nonagon. That got cut off for some reason, but we have all the numbers there. And like I said, pause the video and then check it, and I'll just kind of show my work and just see if it matches up with your own. Let's go ahead and recap what I got here. Hopefully you ended up with 140 degrees for each angle of a nonagon. I just did 1260 divided by 9. 1260 is the number of degrees that are in a nonagon, and 9 is the number of sides and the number of angles. So 9, when you divide that by 9, you get 140. All right, for this one, when you add up all the numbers that are given, you get 1,075. X represents the part that we don't know, so we set up a simple equation. This is a one-step equation. I know the numbers are a little bit bigger than you're used to, but it's just a one-step equation, and you're allowed to use calculators on this. And when I took away 1,075 from both sides, I ended up getting 185 degrees. So that's what X is. And if you don't agree, or if you don't trust that answer, for instance, you can always just go back and add them all up again. 125 plus 142 plus 140 plus 136 plus 118 plus 123 plus 160 plus 131 plus 185. And that should come out to 1,260. If it doesn't, then something's up. Yes, something's wrong with your math there. So that does it for your lesson here. Hopefully you understand this. Today we talked about, really the point of the lesson today was kind of talking about individual angles. of polygons and individual angles of irregular polygons. All right, so that does it for your lesson. Everyone have a great day, and please let me know if you're confused on anything that I've covered or if you notice a mistake or something's up. All right, so everyone have a great day.